Circle, 8 kilograms is described in a circle, constant speed v. Now, see the constant speed v? I'm straight away thinking f sub c is mv squared over r. Now, remember not to be on any devices. Okay? Now, it is connected by a light inaccessible string of length 3 meters to a point 1 meter below, which is above the vertical circle. So I don't think there's any. Oh, it is on a table. So it's the usual parallelogram ellipse thing. So I said they're getting slightly repetitious at the start, are they? It's always a. Yeah, it's an easy start anyway. Yeah. Yeah, you can probably help me out with this. And then what's happening is it has a fixed point P above it, and then if you will, I'll use this pink thing. This part here, the little square thing, that's your 8 kilogram mass, okay? And what's happening is it's spinning around like this, okay? And it's constantly, yeah, and it's always aiming towards, its acceleration is always aiming towards the center of the circle. Now what we know is that it's 1 meter here and 3 meters here. And if I do Pythagoras' theorem, the other side's going to be root 8. Is that okay? It was like 3 squared equals 1 squared plus x squared, and then 8 x squared root a equals x. All good? Okay. Now that we've established that, I'm going to use an angle x. Okay. So we'll use angle x here. And what I can say is that cos x is root 8 over 3. And sine x is 1 over 3. We all good with that? Okay. Then I'll get rid of those numbers now, because I don't really need them anymore. Oh, I'll put down the radius as root 8 actually. Radius of motion, root 8. Now, I'm going to transfer onto tension now, okay? So here's your tension, your T value, acting along this line here. Everybody see it? Tension is acting directly right up. Your mass of your particle, guys, what is it? HE acting downwards. Is it currently in contact with the table? Reaction force R. Okay. Would you all be happy that that's T cos x and T sine x going up and into the center of the circle? Okay. So towards the center of the circle is your centripetal motion. Your FC is T cos x, and we all know T cos x to be root 8 over root a over 3t equals mv squared over r. Is that all right? That's your, and then what's the other equation I have to do? Up versus down. Okay, who's going up? R's going up. Anybody else going up? T sine x, otherwise known as 1/3 t. Okay, so we're very much getting a rhythm on these ones. And then what does that equal? mg? What? 8g, yeah. M is actually 8. Now I can go back up here and start putting in numbers. What's m? R? Now this is actually handier than you think, because the root a multiplies by the other root a to become 8, and then the 8's cancel on both sides. So the root 8's and the 8's will actually cancel each other off. Does everybody get that? When you multiply root a, this root a, by this one here, it's just 8, and then the 8's cancel. So then I also have to do then is just cross multiply up to 3, and I get t equals 3v squared. Easy money there, okay? Now we're going to go down to part 2. It will remain in contact with the table if the velocity is less than hg. Remember I said the faster the velocity, the more likely it is to leave the table. So I'm going to put the r value to 0. I'm going to do 1/3 3v squared. And then what I'm going to say is phi squared equals 8g. So at the point where it goes to leave the table, phi equals root 8g. However, any faster than that, I leave the table, don't I? So it's just phi less than or equal to. Actually, let's read it. Has to remain in contact. So if it equals the R value 0, so it has to be less than. Everybody got that? Okay. Lastly, if the speed is increased beyond that point, so here's your problem now, okay? That's your speed, which means you're no longer in contact with the table. The table is gonzo, because you're technically above it, aren't you? That means your R value, gone. 0 or gone, yeah? Whichever way you want to treat it. Now we're going to go back to our two equations, okay? We're going to do up versus down. This was the old up versus down, wasn't it? Good work. The old up versus down right there, yeah? And what do we say about the R value? Gone. Okay. So I'm just going to get rid of that then. Okay. So just a third t equals 8g. I go over here. And this is still true, except the we know what the v value is. What's the v value? Oh, the R value is not root 8 anymore. Can anybody tell me why the R value is not root 8 anymore? So, do you remember earlier we calculated that root 8 because it was, what was it? It was 3 across, 1 up, and we calculated root 8, didn't we? Yeah. But the whole point is your height has now decreased now. Because you're spinning it faster, look. The height is from my thumb. And then when you spin it faster, it goes up. So what's happening is as it spins faster, oh, that's not what I'm trying. Okay, this is your current ellipse around there, yeah? Now you're spinning faster. So your next ellipse is a bit like this. The radius has got bigger, but the height has got smaller. Okay, so that's what we're dealing with there. Okay, so basically we don't know the radius. Is that okay? So this is height, h is here, and r is here. And it's still obeys Pythagoras' theorem, where h squared plus r squared equals, and I'm going to get rid of the root 8 because I don't want that anymore, yeah? Alright, then I go down, and I go, okay, what are we going to do here? Well, I have to put r in here, don't I? Now, everybody see t on this side? Would everybody agree that t is 24g? So what am I going to do with that t there? 24g, okay. All over? 3. We know what phi squared is. Phi is root 9.1, so phi squared will be 9.1g. So it's 8 times 9.1 g all over the radius, yeah? And our goal is to isolate the r value. So I'm going to be lazy here. I'm going to do it all in one go. I'm going to bring the r up. I'm going to bring the 3 up. So it's going to be 3 times 8 times 9.1. The g's cancel. And then on the bottom is root 8 or 24 times root 8. Will somebody throw that in the calculator for me? Let me know what you get.
67.88.
67 point?
1.21.
I like their answer. Was it 3 point what? It has to be below 3, doesn't it? Why does it have to be below 3? 3 is the hypotenuse. And we're currently after the radius. So what did we say it was again?
3.22.
That means we made a Mistake. In this video, we realized that the R value we got is too large because it has a maximum length of 3, which means the R value has to be smaller than 3. So I'm quickly gonna run through the full thing from scratch nearly, okay? Is everybody happy that 1/3 t is 8g? The sine value is a third. T sine x up versus down. So I think we're all pretty happy with t is 24g. I think we've just cleared that, have we? Is that all right? Then, oh, I realized what we did wrong. We used angles from the first part of the question. So those angles don't exist anymore. Do you remember when we said t equals a third and t cos x equals, that's from the old one. We're now on the new one. So unfortunately for me, that's the mistake we made, all right? So as it turns out, cos x and sin x need to be updated. But that's reality. You're going to make that mistake in the test, and we knew we were wrong, didn't we? Because the R value was too big. Then we went searching, the maths added up, which means something in our setup was wrong, and here it is. I wish I would say I did that on purpose, but I didn't. Right? So that's 3, that's R, and that's H. And then cos is adjacent over hypotenuse, so it's R over 3. And sine is, okay, now we're going to come back down again, okay? We're going to go for this again. And I'm going to rub out all this. All this is gone. No use to me anymore. Here we go. Okay. Can we say that it's t sine x? Agreed? And here is t cos x equals what? mv squared over r. Okay. And what I'm going to do is I'm going to isolate t on both equations. Why will I isolate t on both equations? Can anybody tell me? I can use them against each other, can't I? So actually, before I do that, we'll change sine x. What's sine x equal to again? H over 3. So would everybody be happy that t is, what are we going for? T is 24g over h. All good. Then we go over here, and what's cos x again? R over 3. TR over 3 equals, m is 8. Phi squared is 9.1g. And R is R, yeah. And then, I suppose what we're going to get here is, that R goes down there, doesn't it? Whew, that's not nice. So that is going to be 24 times 9.1g all over R squared. Something is up. I'm just going to look at cos x one more time. Cos x is R over 3. Ah, it's mv squared. That's what the issue is. Never mind. All good. Yeah, everything's hunky-dory. Is that okay? Put them equal to each other. Okay, what happens to the g's? And then what do we get then? Well, not R4 here, I'm afraid, alright? So look at this. I'm going to keep the R squared there, yeah? And remember I spoke about Pythagoras' theorem earlier? Actually, we don't need the R4. Oh, I'm silly Billy. See this here? We're going to make it easier this time. You looking? 3 squared equals... yeah, it does. Equals h squared plus r squared. You got that? And what is r squared equal to? So why don't we do 9 equals h squared plus 9.1h. And actually we just have a quadratic now. Straight into the h value. Easier. You didn't have to do the r to the power 4 one. That's slightly nicer, is it? Alright, go on. Somebody do the minus b formula on that for me. So h is 9 over 10. Or h is minus 10. And the h value is 9 tenths. And that's the answer, yeah? Alright, ball.